Good afternoon, Dr. Sharina. My name is Sim, and I am about to present my Simulink assignment. First is a summary of the transfer function. This is a control system and subsystem arranged by using the Simulink software. For servo control, this is the comparison between P, PI, and PID controller. For P controller, we key in the value of KC, and the observation and the values of error is recorded in the table on the left hand side. And for PI controller, we key in the value of KC and tau I. And for PID controller, we key in the value of KC, tau I, and tau D. On the right hand side, we have the comparison of response curve for each controller. Next, for regulatory controller, the procedures are the same. For P controller, we key in the value of KC, and for PI controller, we key in the value of KC and tau I. For PID controller, we key in the value of KC, tau I, and tau D. The observations and the errors are recorded in the table as well. On the right hand side, the comparison of the response curve of each controller is shown on the right hand side. For both servo and regulatory control, PID controller shows the lowest value of errors, and its response curve shows the lowest amplitude and fewer oscillation compared to the P controller and PI controller. And that shows that PID controller is the best controller in this case. This is a control system for multiple set points and disturbances. For the servo control, the step time is set to be 1, 30, and 60, and the set point is set to be 15, 30, and 45. The observations for each controller and errors are recorded in the table as well. For P controller, the KC value is inserted, and for PI, the same value of KC and tau I is inserted, and for PID controller, the same value of KC, tau I, and tau D is inserted. On the right hand side, we have the comparison between each controller. For regulatory control, the procedures are still the same. The observations and errors are recorded as well, and the set point and step time are still the same. On the right hand side, you can see the comparison between each controller for the response curve. And for both regulatory and servo control, the PID controller is still the best controller for this case because it shows the lowest value of errors, and its response curve shows the lowest amplitude and fewer oscillation. Next, we move on to Ziegler-Nichols tuning method. The new KC values and new KC, tau I, and tau D values are calculated by using the formulas. And after that, we key in the new value into the control system, and on the right hand side is the graph we obtain from the new values of parameters. We can show that the response curve changed significantly in terms of the oscillation and amplitude. For Cohen-Kuhn tuning method, the new values of KC, tau I, and tau D are calculated as well, and after we use the new value of parameters, the response curve is shown on the right hand side, and the value of errors is shown in the table as well. Next, we move on to the Simulink software. This is the control system of the multiple set points and disturbance. Now we key in the value for PI controller. The KC value is 1.6 and the tau I value is 0.25, and we let it run, and this is my value. This is my response curve. And for the normal control system. This is the value of KC, this is the value of tau I, and this is the value of tau D. And we let it run, and then this is the curve we get for PID controller. So that's all from me. Thank you.